Okay, guys, so let's do a little organic nomenclature. Nomenclature just means a system for naming things. So we are going to focus mainly on hydrocarbons. We might get to a few oxygen-containing groups, but very unlikely. We don't have much time left, and that's fine with me. So, a hydrocarbon means just that it contains mostly hydrogen, carbon. It could contain oxygen, nitrogen. IUPAC, the International Union of Pure and Applied Chemistry, has set up a set of rules that we use for naming. And it consists of at least three possible parts, and it could have a couple more depending on how deep we get into it. And the first part is a prefix, and that is used if there's like a ring or something like that. Then there's the stem. The stem tells you how many carbons are in that longest chain. And then there's a suffix, and that ending tells you what kind of bonds are in those that long chain of carbon. You will have to memorize the stems for carbons 1 through 10. And I will go through each suffix and prefix as we need them. And there is a huge variety of compounds in organic chemistry. In fact, almost all of your biomolecules are organic. Almost all of your drugs are organic molecules. There's a few, very few, that are not. There's hundreds of millions of possibilities. So, in this slide, I have a few variety of compounds to try and give you an idea of what I'm talking about. The first one on the list is caffeine, and that's this molecule here with the oxygens and nitrogens. And you can see this is quite complex, but there is a systematic way of naming it. Caffeine is what we call a common name for it because it was named before we actually knew the structure and was based on its properties. The second one on the list is isopropyl alcohol, which is this one here with the OH group on it. And there are 3 carbons long, so that's where we get the propyl. The OH is attached in the center carbon, that's where we get the iso. But if I were to name this as an IUPAC name, it would be 2-propanol. So, the next one on the list is gasoline, which is primarily a mixture of 8 carbon-long chains. They may be straight or branched. Octane is the example. A lot of your biomolecules like RNA, DNA, lipids, fatty acids, carbohydrates, all sorts of things like that are organic molecules. As you can see here with deoxyribose, it is a 4-carbon chain with an O in the middle of that ring. And there's all sorts of ways of naming these because of it being a sugar. And this one would be RNA, and then this is a T or thiamine in DNA, and a U or uracil in RNA. And you can see how those two are slightly different, and that's how they have different properties. And I figured we might as well talk about things that go boom. And so TNT is trinitrotoluene, and so the carbon chain that's called toluene is this benzene ring plus this 1 carbon out here. And so that would be toluene. And then we have 3 nitrate groups, which gives us the trinitrotoluene. So the stems that you need to know, and you probably need to pause this and write these down. You're going to need these every single day of next week. Meth for 1 carbon, eth for 2 carbons, 3 is prop, 4 is bute, 5 is pent, 6 is hex, like a hexagon, 5 is like a pentagon, 7 is hept, 8 is oct, 9 is non, and 10 is dec. So, rules for hydrocarbons. You want to find the longest carbon chain. Then you're going to want to highlight that longest chain. And I really recommend a highlighter for this. You could circle in a color of ink, but I would suggest a highlighter. Then you're going to number from the end closest to the first branch, and this is for specifically alkanes. As we get higher up, we'll have more rules for different complexities, different other groups that are attached. And you want to write the names for the substituents, and substituents are things that you did not highlight in step 2. So if it's not highlighted, that means it's not in the longest chain, so it's a substituent. And the substituents go first and they go in alphabetical order, not in number order. So if we had a 1 carbon group that's methyl, and if we had a 2 carbon group that's ethyl, ethyl would come before methyl just because it's alphabetically first. Then the last thing you're going to do is put in your stem and then your suffix. So your stem would be however many carbons is in that longest chain. And then the suffix, so far as all you know, is going to be ane because we're dealing with just straight chain carbons, all single bonds. So the suffix that I'm giving you today are ane, ene, and yne. If it has a single bond, all of the bonds between carbon atoms are single, it will end in ane. If it has a double bond anywhere in the compound, then it would be ene. If it has a triple bond, it would be yne. So, if your carbons are a ring, you would add a prefix of cyclo before the stem name. So that's your first prefix, is cyclo. So let's look at a couple examples. If we have halogens, you drop the ine from the name, so chlorine would become chloro. Fluorine would become fluoro, etc. If you have more than one of the same group, you use di for 2, tri for 3, tetra for 4, etc. So let's look at this very first carbon over here at the very left-hand side. We have 3 carbons on our longest chain. So if we go back to our stems, that gives us propane, and it's ane because they're all single bonds. Here I've changed one of the hydrogens out for a chlorine, so it becomes propane still, but then you have to tell me the location of that chlorine. Is it on carbon 1, 2, or 3? And it can't be 3 in this chain because we just number the other way. We always number from the end closest to the first substituent. So 2-chloropropane because it's on the second one, not the first one. So here, instead of having a chlorine coming off, I have a 1 carbon chain coming off. So this is still going to be propane, and I could number in either direction. It is coming off of carbon 2, because if it came off of carbon 3 or 1, then it would be in the longest chain. And so this is 2-methylpropane. Here we have 6 carbons long, and on carbon 2 and on carbon 4 we have a fluorine. So we're going to get 2,4-difluoro, and then the longest chain is 6, so it'll be hexane. Here we have a bromine on carbon 1 and a chlorine on carbon 3. We are not putting them in number order, we're putting in them alphabetical order. It's still 6 carbons long, and I always name the longest chain first. So I write out hexane, then I write we have a 3-chloro and a 1-bromo. So it would be 1-bromo, 3-chlorohexane. Here we have a group of carbons that are in a ring. And so we count how many carbons there are, and we add the prefix cyclo. So this is cyclohexane. So how about you try a few of these? I want you to stop and pause the video here. I do have answers on the next page. Okay, so we have 3 carbons long. This would be propane. This is 1, 2, 3, 4, 5, 6. So this is going to be a hexane. It has 2 methyl groups on carbons 2 and 3. So 2,3-dimethyl hexane. This is a group that is in a ring. So it's going to be cyclo. There's 4 carbons, so cyclobutane. So methyl cyclobutane. You do not have to put a number here, but you can if you wish. The reason you don't need a number is because wherever that branch comes off would be carbon 1. Here we are going to need some numbers. And when we do this, we'll see that this would be the methyl group is 1. So this is carbon 1. This will be carbon 2. I don't have to number the carbon as 1. So it would just be 2-iodo methyl cyclobutane. Okay, so thanks for watching. I will talk to you later.